A magnetic starter is a simple device that aids in the starting, stopping, and protection of low-voltage electric motors. The magnetic starter consists of two basic components, the contactor and the overload block. When combined, they are electronically interlocked using a normally closed contact to disengage the contactor in the event of an overload. In this combined configuration, the device is called a starter. Contactors use one set of stationary contacts and one moving contact per pole. The opening and closing action of the contacts is produced by an electromagnet and control coil. When voltage is applied to the control coil, it creates a magnetic field that pulls the armature and magnet together, forcing the moving contacts firmly against the stationary contacts into the closed position. Remove the control voltage, and the spring-loaded armature returns the contacts to the open position, removing power from the motor circuit. At startup, electric motors draw an enormous amount of current to initiate rotation and bring the motor up to speed. Once a motor is up to its optimal speed, current draw drops dramatically. The maximum current draw at startup is referred to as the inrush or starting current. This inrush current can be upwards of 7 to 10 times the actual running current of the motor. While this current load only lasts for a few cycles of the waveform, it diminishes drastically as the motor armature begins to rotate and spins up to its operational speed. The current draw of an electric motor under its rated full load is referred to as its full load amperage, or FLA for short. This FLA is the design limit of allowable current load for the motor. Now, when a motor receives current loads above this limit for any prolonged length of time, serious damage will occur. This important piece of information will always be found on the motor data plate and is also listed in the manufacturer's data sheet for the motor. This current draw information is critical when sizing the starter and the overload heater elements required for proper motor protection. To correctly identify the proper size NEMA-rated starter, you will always need the motor voltage, horsepower, and full load amperage. The overload section of a starter, just as its name suggests, protects the motor from an overcurrent condition. It does this by using an inverse time delay function. This is accomplished by means of thermal detection or electronic detection to limit the total current draw, plus a calculated percentage limit above it. Thermal heater elements conduct the motor load current, producing heat proportional to the current, and will open the overload unit contacts if the motor current draw becomes excessive due to a mechanical overload condition. Electronic overload units, just as the thermal detection, sense the motor load current. However, they use current transformers and microprocessor control to determine when it is prudent to open the overload unit's contacts, not heat. And when the overload unit of a starter senses an overload condition, the normally closed contact opens. Wired in series with the holding circuit of the contactor, this opening of the overload block holding contact removes power from the motor by removing the control voltage from the coil and opens the starter contacts. In some critical motor operations where nuisance tripping is to be avoided, other factors such as ambient environmental conditions, enclosure type, and its size also contribute to calculating the limit of current draw allowed to pass through the overload unit before opening. While thermal elements are not adjustable and are selected from factory tables for specific loads, electronic units are adjustable for a fixed range of full load amperages and must be selected according to the specific range suitable for the motor. As with any device carrying electrical energy, heat is generated by its operation. Heat is the primary enemy of a magnetic starter. Heat can not only degrade performance, it can damage the starter beyond repair. Heat damage can be costly if not found and corrected early for both the starter and the motor. If not kept to normal operational limits, serious damage can occur to the whole system. Here's a classic example of heat damage. As you can see, the housing is discolored and has become brittle. The dielectric strength, its ability to contain the electrical energy safely, is severely compromised and all the internal components are damaged from the excessive heat. Once a starter has reached this condition, it must be replaced. Rebuilding is not only unwise and wasteful, it is unsafe. The primary contributory reasons for excessive heat are improper sizing of the starter itself for the horsepower, voltage and current draw of the motor, improper wire sizing for distance, current, and voltage drop, improper torque of electrical connections, low or improper control voltage leading to armature chatter, worn or severely pitted contacts, dirt and dust contamination. Now, any one of these situations will lead to failure and motor damage if not found and corrected. When replacing a motor, always verify the existing starter, line, and load side conductors and overload elements are sized properly to work with your replacement motor. Never assume all is well. A common contributor to starter and motor failure is in assuming the existing equipment will handle the replacement motor. If any of these factors are not sized and rated correctly, time, labor, equipment, and money are wasted by not ensuring all is well from the panel to the motor. It's an engineered system where every part of the system works together happily. If you change one variable and not verify the others are within their correct limits, failures will be sure to happen. Do your homework, and you can be assured all will be well. Remember to always use standard safety precautions when removing and installing magnetic starters, and always verify every component of the system is correctly sized. All connections are tightened properly, and every component of the system is installed per current National Electric Code standards for motor applications and installation. When a starter is properly sized, installed, and serviced, it should last the life of the motor and beyond. Proper care and maintenance of your control equipment will give you peace of mind and save your company from unexpected and costly expense. Check out our other videos as they become available, and don't forget, Charter Contact offers a full range of motor control and power distribution parts and rebuild services. Our vast inventory and experience is available 24/7. For all your motor control needs, call us at 877-882-2668.